Hello everyone, this is Ron Armstrong with Matos Designs. Today I'm going to talk about 4-channel RGBW pixels, specifically our Evo Domes. Our Evo Domes are a new pixel type that we announced this year, and they are 4-channel RGBW, and the W 4th channel is a warm white. So a lot of questions on how do I get them configured in xLights, and hey, I've got these new pixels but they don't light up right. What's going on? So I'll talk a little bit about my setup and then we'll get into those details. So I happen to have in my lab here right now a Matos Designs Dragon 8 controller. Got a little Raspberry Pi FPP. We're not really going to use the FPP for this demonstration other than to show you test patterns and why we may or may not use those test patterns. But we're going to do all of our work in xLights. I happen to have a layout here with a couple of mini trees. This left mini tree with the star is standard 2811 bullet pixels. And the right mini tree is our Evo Dome RGBW 4-channel pixels with a dedicated white channel, with a dedicated white LED. Also have a little camera up here in this picture-in-picture up in the corner. You can actually see those in real time. However, that camera feed is 4 or 5 second delayed. So when I start testing and seeing in real world what do we see and what's happening on the real models, that might be a little bit delayed, but it should be captured on the video. On the controller, I just have these models placed. Let me go back to xLights. We'll save, go to visualize. You can see I just got port 1 going to the medium tree with the star, and port for 200 total pixels, and port 2 going to the mini tree and star for a total of 100 pixels. And if I look at my controller, you can see, and let's refresh this, you can see that the controller output page is defined because I did do an upload output from xLights in order to get this configuration. You'll observe and notice that the type of pixels listed is RGB pixels. The particular settings may vary from controller to controller. So our Matos Designs Dragon 8-port version 1 controller is based on the Genius technology, and so the Genius controllers and our Dragon controller is going to configure exactly the same way within xLights. So you can configure this manually, but we strongly prefer to make all configuration changes in xLights and then upload output to the controller. That way your controller is always configured to match xLights. So those who have been doing shows for a little bit know that xLights has to be configured properly with your proper models and your controller, and if you use FPP, it has to be configured properly as well. On the controller page here, I'll have you observe that the drag controller currently has 900 channels associated with it because I got a 200 pixel standard RGB pixel and a 100 RGB W pixel. Right now, that is showing as 900 because I've made no configuration changes yet. I'm going to do most of my testing from the sequencer in xLights. I basically just created an empty animation sequence, grabbed the on effect and dropped the on effect onto my all group. So if I highlight the on effect, you can see that it's going to all of the trees. I'm going to output to lights. They did come on in real world. The camera will catch up here in a second, I hope. There you go. So I'm testing in xLights and I have like this red color, but oh, wait a minute, my tree is not doing red. Why not? Because the xLights currently by default is going to configure for RGB pixels, which are 3 channels. So 100 pixels gets 300 channels of data, and that's what it's sending out. But these pixels consume 4 channels of data each. So I'm only getting 76-ish some pixels. And you'll notice that not all of the pixels over here on the right edge and the star, all of the pixels are not lighting up because the other pixels are consuming all that data, causing it to display a mix of colors. This is something you may have run into if you've started playing with 4-channel RGBW pixels. So I just change that to green. The camera will catch up. It's about 5-second delay, it appears to be. And so, my left tree is green, but the right tree is still mixed because it's not configured correctly yet. Okay, I'm going to turn off the output to lights for now, and let's go back here. So now how do I configure it for 4-channel RGBW pixels? So this little tree and the little star are the models we're talking about. There's actually 2 places you need to configure it in xLights. So we need to tell xLights that they are 4-channel pixels, so it allocates enough channels and so that it sets it up correctly for a 4-channel pixel that has RGBW. But we also have to tell the controller that they are 4-channel RGBW pixels. In xLights, you're going to scroll down in your properties box for your model. So select your model in your properties box. You will have a section titled controller connection and string properties. These may be collapsed, so just expand them out. Controller connections are a set of attributes that you can define on this model that xLights will use to configure the controller for you when you do upload output. So things like you can set a specific brightness for this model, you can set a specific gamma, specific color order, or null pixels. The values that you see in this controller connections are very dependent on the capabilities of your controller. So if I'm using, in this case, my Dragon controller from Matos Designs, which is based on the Genius technology, so I will expect to see these same connection types for Genius controllers. But Falcons or Culps would be maybe have some other settings or not as many settings as the case may be. Defining 4-channel RGBW pixels in xLights are the method I'm going to describe to you should work fine for Genius and Falcon and Culp controllers, which Culp controllers are based upon FPP. So any FPP-based controller should configure the same way as well. Other controller types like your WLED-based controller types, a lot of people are using like various ESP device controllers with WLED software. Configuring 4-channel in them is quite different, and I'm not going to cover that in this video, but it is different. So to get started real quick, we're going to tell xLights that these are RGB nodes by going to the string properties on that tree and choosing RGBW nodes. That tells xLights that these are a 4-channel string type with RGBW. That actually opens the door for RGB color handling. So color handling, there's 2 choices that you could use. RGB only is the default, which means when you turn these lights white, it will be a mix white. It will take the RGB values and it will actually send that to the RGB channels and produce a mix white, which is not your true white 4th channel, your white LED. So the color handling RGB greater than W is what will actually tell xLights to output the correct value to the white channel to take advantage of that white pixel. Let's just demonstrate that on the tree here real quick. We're only changing the tree at this point. We'll come back and change the star in a moment. So I'm going to leave this on mixed white for now. We'll take a look at what that looks like in the camera, even though it'll be a little bit washed out in the camera. And then we'll change it to RGBW, see that, because these Evo Dome pixels, the white channel is a warm white, and it is noticeably different. So this takes care of the xLights part. To tell the controller, I'm going to set the controller order, check mark that, and then change the controller order to also be RGBW. The Evo Domes, the correct color order is RGBW, yes. If your pixels have a different color ordering, then likely you would want to specify that in just one of these locations. Do not do your color order change in both locations, as then you're getting a kind of a double flip. So for the case of Evo Domes that I'm talking about today, it's RGBW, RGBW. This technically does no changes at all until you upload outputs on the controller. So I'm going to save my changes, go to the controller tab, and hit upload output. Now that I've uploaded output, and down here in the bottom left corner, you can see upload complete. And I'm going to go to my controller. I'm going to refresh the web page. And you can see that because we set that controller connection property, that has now, when I upload output, it changed this automatically to RGBW pixels. And you'll notice the channel number changed as well to give it the proper number. This is 80 pixels that we changed. So that went from 8 times 3, 240 channels to 8 times 4, which is 320 channels. It went from 240 to 320. Anyway, so let's go to our sequencer real quick. Let's just hit this up and output to lights. And if I output to lights, and then when the camera catches up, you'll see that the trees, both trees are green. The star we haven't adjusted yet, right, purposely. So the star I haven't adjusted yet. So this setting is on a per model setting. So any model that has your 4-channel pixels, your RGBW pixels, you're going to have to make those setting changes on each model. And remember our color handling, we told it to do the mix white. So when I turn this to white, you'll notice that the Evo domes in this white tree will be a little bit more of that bright white, very similar to my other pixels. Very similar. Now let's go and actually change that color handling to send white to the 4th channel. This setting in string properties is xLights only, has nothing to do with the controller, just how xLights processes the color handling for 4-channel pixels. So I now outputting the white. And you'll note, even if it's washed out in the camera, you'll notice a different white. Even though the star is not configured yet, that star is all white, but that's the mix white, right? Because we haven't adjusted that model yet. The star model is a separate model. So we haven't adjusted that model yet. So you'll now see that you get that true warm white because those Evo domes, the white channel is a warm white. And if I go to red, again, about a 5-second delay or so on the camera, not counting, but now everything that we've adjusted is now red. Let's go ahead and fix the star as well. So go back to layout. Now I'm going to select my star model. Again, string type needs to be RGBW nodes, and I prefer the color handling of RGBW for the color handling, so I get that actual white channel. That also, when I output white, that's lighting up that 4th LED only, so it's less power draw because I'm only lighting up the 1 LED. If I'm on the default RGB only, I'm still getting that mix white, so the white will look more like my other pixels because it's a mix white, but that's also lighting up all of your LEDs in a mixed color pattern, so it's a little bit more power draw because you're lighting up more LEDs. I prefer the RGBW. And then we have to set the color order on the controller connections also to be RGBW. Have both those settings. I'm going to make a save changes. I'm going to go to my controller tab, select the controller, turn off output to light so I can upload output. We just uploaded the controller. I'm going to refresh here and see that it actually changed to RGBW pixels, and you notice the channel count changed as well because this is 100 total pixels that are 4 channels. So it starts at 601, goes to 1000. That means it's 400 channels now being assigned, not 300 channels like it was before. You'll notice in xLights that my total channel count has changed also because I've changed my string properties to be an RGBW node. So that changed the number of channels assigned to those models. Now if I go to my sequencer and testing, let's go ahead and select this red again and output to lights. It is all red physically, waiting for the camera to catch up here. All red. Everything's all red. Everything's all green. Wait for the camera to catch up. I know IP cloud-based cameras, right? So the camera is actually, recording to the camera service out in the cloud, and then I'm displaying it in a little picture-on-picture window here. So very not the most responsive of cameras. And if I were to take this, like something like the butterfly effect on all, you can see I now get the butterfly effect going across both trees. So the camera catches up, you can see how that butterfly effect is following both trees, just like you're seeing in the model preview. So recap, each model that has 4-channel pixels, you need to change the string type and the color order on the controller connections. Then upload output to the controller to configure the controller properly. I'm going to demonstrate a little bit here about testing. So if I'm in my controller and go to the testing from the controller, and let's say I wanted to do like a red fade, right? And I have my output selected and I turn test mode on. And when the camera catches up, except my test mode just turned off. It's on again. Sometimes I've noticed I might have to turn test mode on twice for it to stay on. It might come on for a moment and then go off regardless. So you'll notice that the big tree, which is just your standard pixels, is doing the red fade properly. The little tree, which are my 4-channel pixels, are not doing a red fade. The testing patterns in the Genius here and on most controllers, the testing patterns are based upon a 3-channel pattern. So a blue fade will send output to every 3rd channel on the blue channel. So when you're dealing with, even though the controller knows these are RGBW pixels on this output type, the test patterns are still a 3-channel test pattern. So these test patterns that you might perform on your or even color cycle, just have this, go through the colors overall instead of the fading. It'll just cycle color. So if you have a mix of 3-channel and 4-channel, the testing from the controller may not give you accurate results. The same goes for FPP. Actually, let me turn the controller testing off. It's off in the real world. If I go to FPP, and this FPP just has an output to my Dragon for those channel numbers. And if I go to display testing, status control display testing, just turn on my display testing, it will, like cycling RGB, but the little tree, which is 4 channels, are mixed colors because it's still a 3-channel test. Right, even up here at the top, you'll notice that RGB patterns have no knowledge of output setups, models. It's just 1st channel, 2nd channel, 3rd channel. If channels do not line up, then the colors displayed on the pixels may not match. So it's actually a warning right here in FPP. So even if I come down and did like just an individual color test and try to do just like a red only, again, this is like sending red to every 3rd channel, not every 4th channel. So you're not going to get red on both. So the test patterns from your controller and from FPP may not display correctly when dealing with 4-channel RGBW pixels. My strong preference is to always test with a animation sequence, maybe on your all group, and just throw an on effect in there real quick, and then set the colors that you want to be output to lights. Use this because this is processing through what is 3-channel and 4-channel and everything all together, and making sure it's sending the correct channel data to your pixels to be consistent. So test from xLights as just drop an on effect on there, or I'm going to turn output lights, go to tools, test, and xLights. If you haven't used this utility before, models allows you to pick individual models. Control, you can expand and pick individual controller ports to test. And a model, you can specify a specific model, and you can highlight specific pixels, and it will only output on those specific pixels, right? So say I want to test this row right here, then those rows will start testing here as soon as my camera catches up. So model allows you to pick and draw specific pixels to test. Models allows you to test model by model. And when I click the tree, then the tree should be the one that's testing, right? These test patterns, these first sets of test patterns, are also 3-channel based. If I'm testing from xLights Tools Test, the only test pattern that is 4-channel based is this RGBW. These other test patterns are 3-channel based, so I still get my incorrect, if you're observing in the camera, I'm still getting my incorrect output on the pixels because that's a 3-channel test. This is a 4-channel test. And if I pick that tree, do a 4-channel test, and pick my other tree, it will be in color sync from here, so that they will always be red together, green together, blue together, but the 3-channel pixels will be blank for white because there is no white channel. Anyway, so testing from xLights is preferred for shows that have a mix of 3 and 4-channel pixels. So that's the most about, I probably will put in this video for how to configure 4-channel RGBW pixels, specifically the Matos Designs Evo domes. If you have any questions, feel free to reach out to Matos Designs. We'll be glad to help get you sorted out. Enjoy and have a great show season.